As a continuation of the Chapter 10 problems, remember that the whole goal of what we're doing with the variances is that we're going to have a budgeted cost per unit, meaning how much do we think it's going to take to produce one unit, and then we're going to be able to compare it to what it actually cost us to make a unit. Well, it could be more, it could be less. If it costs more, obviously we want to know why, because that's not favorable. To simply just look at the cost in total, you really can't just compare with what you thought it was going to cost versus what you actually, spent to produce the product without digging down deeper. And so that's what really the purpose of the variances is to really pinpoint why the cost is different than what we thought the cost was going to be. So we have to break it down into the different components of the product cost. So we have to break the variances down between the materials, labor, and the overhead variances. And then within that, for example, just looking at material, well, why did it cost us more for the material? Is it because we had to use more material or because the price was more? So within each of those segments of the product cost, we break the variances down even more between the quantity variance or the usage variance and the price variance. So that's what we're going to do in this problem. It says that the company produces single color t-shirts. Materials for the shirts are dyed in large vats. After dyeing the material for the given color, the vats must be cleaned and prepared for the next batch of materials to be colored. It gives us the following standard cost. So for the standard, it gives us the direct material. So basically, what it's showing in a setup such as this is that with direct materials, they're saying that for one batch or for one unit, so to speak, it's going to take 2.5 pounds and it's going to cost 90 cents per pound. So the cost is $2.25 per unit. Okay, so it's multiplied out and it gives you a cost per unit. We, though, are not going to be concerned about the cost per unit. We're concerned about the inputs. So we are concerned about the pounds and we're concerned about the price per pound. So what you're going to be looking at is what's in these parentheses. Same thing for labor. For the labor cost, it's saying that we expect to use 3/4 of an hour and we're going to pay $7 an hour. So that gives you a cost per unit of $5.25. Again, we don't really care about that. We care about what's going on inside the parentheses. We care about the input. We care about the labor hours and the price for the labor. It says during the year, 53 pounds of material were purchased and used. Typically, the amount of material used and purchased is going to be the same versus our previous example where there was a difference. Here, they're going to be the same. There were 20,000 batches produced. Remember, a batch is our unit for this particular problem, and it gives us the actual cost. So we actually spent 42,000 in labor. I'm sorry, 42,000 in material and 102,000 in labor. So we want to calculate the price and the usage variance for both the material and the labor. Okay, so let's start off with materials. And so for the materials, we want to calculate the price and the usage variance. To do that, we want to type out our 3 columns. So we have actual price times actual quantity. We have standard price times actual quantity. And we have standard price times standard quantity. So dealing with materials, we want to know what we know about the actual. And here, they've already done some of the work for us, which is great. They've told you that the actual cost of the direct materials was $42,000. So they've already multiplied this together for you. Okay, so they've already multiplied the actual price of the material times the actual quantity of the material together, which gives you $42,000. So we can just plug the total number in. Then for the standard price, we want to know how much did we think we were going to pay for the material, and we think we were going to pay 90 cents per pound. So we want to take 90 cents per pound and multiply it by the actual number of pounds, which is 53,000. So that's going to give you $47,700. So once I have column 1 and column 2 computed, then I can take the difference between those two amounts, and that's going to give me the price variance. So if I take 42,000 minus 47,700, that's going to give you a difference of 5,700, and this is your price variance. So your material price variance is 5,700. We have to determine, though, whether it is favorable or unfavorable. Basically, we actually paid 42, And based on the actual quantity, we thought we would have paid $47.7, so we paid less, so that's good, so it's favorable. Now, to calculate the usage variance, we can come over and calculate the third column. So we can take the standard price, which is 90 cents per pound, and then we want to multiply it by the standard quantity. And remember, it's the standard quantity at the actual number of units. Okay, so remember, this is the tricky part. For the standard quantity, really what we're trying to figure out is when we produce the actual number of units. Okay, so when we actually produce the actual number of units or batches, how much material should we have used? And so we should have put 2.5 pounds in each unit. So that's going to give you your standard quantity. So when you multiply that out times the 90 cents per pound, that gives you a cost of $45,000. So now to calculate the usage variance, I just take the difference between $47.7 and $45,000, and that gives you $2,700, and that is going to be an unfavorable variance. If you take the $45,000, based at the standard price, for the standard quantity, it should have cost $45,000. But it actually cost $47.7, so that gives you an unfavorable usage variance. That's the worst. That is worse. To come up with the total variance, you can take the difference in the two far outside columns, so $42,000 versus $45,000. That gives you a $3,000 total variance, and the total variance is going to be favorable. We thought we would spend $45,000. We actually spent $42,000, so we spent less, so that's good. So that makes it a favorable total variance. And that's all you have to do for the materials. Now moving on, now we'll do the same thing for the labor variances. So same thing for labor. We want to calculate the labor rate and the labor efficiency. So we need the three columns: actual price times actual quantity, then standard price times actual quantity, and then standard price times standard quantity. And fill in everything that you know. For labor, same thing. They've helped us out again for the labor cost. For the total, they have said that the total labor cost is $102,000. So they've already multiplied it out for us. For the standard price, remember what you're looking for is inside the parentheses because we're worried about the input. So what we think we're going to pay for labor is $7 per hour. And we want to multiply that by how many hours were actually worked. So that's 14,900. So when I multiply that out, that's 104,300. So now I am able to calculate the rate variance or the price variance. So I'm going to take the difference between 102 and 104,300. And so that gives you a difference of 2,300. The variance is going to be favorable because we actually spent 102. We thought we would had to have paid 104,300. So we paid less, so that's good. That's favorable. So we have a favorable rate variance. Rate and price mean the same thing. Now we can fill in the third column and calculate the usage or the efficiency variance. So your standard price is $7. For the standard quantity, again, this is where it gets tricky. For the labor, we expect to use 3/4 of an hour to produce each unit or to produce each batch. So I've got to multiply the labor cost per batch times the actual number of batches. Multiply that out times the $7. And so that gives you $105,000 as your expected cost. So now to find the usage or the efficiency variance, I'm simply going to take the difference between 105 and 104,300. That's going to give you a $700 difference. So based on the standard price with the actual quantity, it would have been 104,300. But with the standard quantity, it should have been 105. So that means we were more efficient with the time. So it's a good thing. So it's going to be favorable. So we have a $700 favorable efficiency variance. It could also be called a usage variance. And then last, we could calculate the total variance. So to calculate the total variance, you can either take the difference in the two far outside columns, so take the difference in the 102 and the 105, or you can also add together the price variance and the usage variance. So either way, obviously that's a $3,000 difference. So if you add 2,300 and 700 together, that gives you 3,000. They're both favorable, so you're adding together two favorable variances to come up with a $3,000 favorable. So total. So you have a $3,000 total labor variance. So again, just to recap Chapter 10, we're concerned about looking at the inputs. We want to see if there is a breakdown with the price and the usage for materials and for labor. Different people are going to be held accountable for different pieces, different components, so that's why we want to break it down into two different categories. Once you can remember your three columns, really the calculations is just a matter of filling in the different pieces. The piece where people find the most challenging or have the most trouble is with the standard quantity. So just remember for your notes, you want to write down that it's a standard quantity per unit times the actual number of units. If you can remember those small things, you shouldn't have any trouble calculating the variances. If you have any questions about anything we've gone over, any of these practice problems or any of the additional practice problems, please feel free to come by and see me.